This is the Chem 1 lecture over density. So density is a way to describe matter. It's a way to look at both mass and volume together. So it's a ratio of how much mass is combined into how much space. The closer the molecules are together in a volume, the greater its density. The closer they are together, the more smushed they are. Now, density is an intensive property, so it's independent of amount, so which means you can actually use it to identify an unknown substance. If you don't know what it is, maybe if you knew the density, you could figure it out. So some of you guys may have done density calculations before, and you might learn that density is equal to mass of whatever substance over its volume. So those are options, units. There's a whole variety of units that could be. It could be any unit of mass divided by any unit of volume. So one you're going to see pretty frequently in here would be grams over milliliters, since those are both metric units. You may see something like grams per centimeter cubed. Centimeters cubed is another unit of volume, but you may have crazy English units. So what if we had pounds per gallon? You won't see that too often in here, but that's still a mass over a volume, so it still counts as a unit of density. So let's go through and think through some conceptual ideas about density before we go through and do some math. So up here I've got two boxes. I got box A and box B, and I got some red balls in there. That's all I know. And the question is, which block has a greater mass? Well, I would choose block A since it has more of those red balls in there than B. But which one has a greater volume? Let's look. Well, the size of these boxes, they look very much the same. Since they're the same, that means the volume is the same. So next, which block has a greater density? Well, since block A has more stuff for the given volume, I would say that A is more densely packed. Let's see the next one. Let's see, we've got this block, and it says if it were cut in half, what would be the relative density on both halves? And we're actually given some numbers. So our first block, I know the mass is 200 grams and the volume is 100 centimeters cubed. So the density would end up being mass over volume, 200 grams over 100 centimeters cubed. That is, what is that, 2 grams per centimeter cubed. Let's look over if we cut the block in half. Okay, so we have 1/2 of it over here. Let's see, the mass would be halved, so we would have half as much mass, 100 grams, and half as much volume. So the density would then be 100 grams divided by 50 centimeters cubed. Guess what? The density would be the same, 2 grams per centimeter cubed. The halves would be the same. So the way I think through that is I know density has to do with how closely packed those particles are. So if I took something like a block and I cut it in half, did I squish those particles closer together, or did I expand them? I didn't, right? Those particles are still the same distance apart, I just have less of them. But if I have half the mass and half the volume, I ended up with the same density. So this is where you can see that mass and volume are extensive properties. Those do change when you change an amount, but when you put them together into density, you actually end up with an intensive property, something that's independent of amount. So next we've got some density problems. We are going to be using dimensional analysis again, that way we can get any kind of unit conversion done in with the math. We are actually not going to do algebra on these. I'm going to expect to see density done with dimensional analysis. So our first example, a rectangular piece of cement has the dimensions of 2 by 2 by 3 centimeters. We need to calculate that density in grams per centimeter cubed, and we're given that the mass is 0.108 kilograms. So first, if we've got these dimensions, we need to find the volume. So remember, the volume is going to be length times width times height. So in this case, it's going to be 2 centimeters by 2 centimeters by 3. So we've got to take all 3 of those dimensions and multiply them together. I'm going to ignore sig figs for a second. 2 times 2 times 3, let's see, 2 times 2 is 4 times 3 is 12 centimeters cubed. And let's see, we have 3 sig figs in each number, so I need 3 sig figs in my volume. So there's half of my problem. I know density is mass over volume, so I'm going to have to start my t-chart with mass on top. So I'm going to start with my 1.108 kilograms on the top per 12.0 centimeters cubed on the bottom. this is a unit of density, but it is kilograms per centimeter cubed, and we needed to find grams per centimeter cubed, so we don't quite have the right units yet. So you got to keep chugging along here. We got to cancel out my kilograms, so I'm going to put it down there on the bottom. And let's see, converting kilograms to grams, that is a conversion you're supposed to know. For every 1 kilogram, we have 1,000 grams. So once we do that, our kilograms are going to cancel out, so our units are going to be grams up top, centimeters cubed on the bottom, which is matching the units we needed to find. So once we do the math, so we're going to take 0.108 kilograms times 1,000 divided by 12, we're going to get 9. Now, that's not the right number of sig figs. If we go back to the problem, we have 3 sig figs in our numbers, so we need to add 0.00 after our 9 to get 3 sig figs, and the units are going to be grams per centimeter cubed. So, an example number 2, let's see, gold has a density of 19.3 grams per centimeter cubed, so we're given density. We're asked to find the mass in pounds of 7.25 centimeters cubed of gold. So in this case, we have density, so we need to think about density as a conversion factor. So that means if I have 19.3 grams of gold, it's going to occupy or equal 1 centimeter cubed of volume. So that density is going to be a way for us to convert between mass and volume. So we're going to start with our other number. We're always going to start our dimensional analysis with whichever number has fewer units. So it's going to be 7.25 centimeters cubed. Got our T-chart here. So I know I need to cancel out my centimeters cubed, so I'm going to put that down there on the bottom. And if we go back to our density, I know 1 centimeter cubed equals 19.3 grams of gold. So at this point, we have canceled out our centimeters cubed, and we have grams, which is completely a unit of mass, but not the unit of mass we were asked to find. We're actually asked to find pounds. So we need to keep on going. So I'm going to extend my T-chart here. Got to cancel out my grams. I'm going to put it on the bottom. And this time we were asked to convert it to pounds. So if you weren't sure what the abbreviation for pounds were, you could write out the word pounds. I happen to know that it's LB. And let's go back. We're given that conversion factor up here in the problem. I see 1 pound. 1 pound is 454 grams. So now that we've done that, grams are going to cancel out, and we're left with pounds, which is what we were asked to find. So now it's just a matter of doing the math here. Multiply across the top, divide by the bottom, so 7.25 times 19.3 divided by 454, that's going to give you 0.308 pounds. Same thing, let's go back to the problem. Each number has 3 sig figs in it, so since we multiply and divide, we need to round to our least number of sig figs. So in this case, it would be 0.308 pounds. So our third example, let's see, the density of sulfuric acid is 1.84 grams per milliliter, so we're given density, and this time we're given mass. We know the mass is 25 grams, we're asked to find the volume in liters. So same thing as before, I'm going to really think about density as a conversion factor. So 1.84 grams of sulfuric acid would take up 1 milliliter of space. I'm going to start my dimensional analysis. I've got 2 numbers in the problem. I'm going to go ahead and use the one that has fewer units. 25.0 grams is what we're going to start with. 25.0 grams. Dimensional analysis, same thing. I know I got to cancel out my grams. I got to throw it down there in the bottom. Well, we can go ahead and use density since that has grams in it. We can go from grams to milliliters, and that's 1.84 grams for every 1 milliliter. So when we do that, we've now canceled out grams, and we have milliliters, so we have volume already, but we were asked to find volume in liters, so we're not quite done yet. Got to keep going. Cancel out my milliliters, and we can actually go between milliliters and liters. That is a conversion factor, that prefix milli. If you remember, that means 1,000th, so that means there's 1,000 milliliters for every 1 liter. So now that we've done that, milliliters cancel out, we're left with liters. That's what we were asked to find. So now we just need to do the math here, multiply across the top and the bottom, and then divide. So it'd be 25 divided by, and then important, be sure you put your denominator in parentheses since there's more than one of them, 1.84 times 1,000, and you're going to get a pretty small number here. You're going to get 0.0136 liters. So same thing, the numbers in the problem were multiplied and divided, so we need to run to our least number of sig figs, which was 3. There we go. So remember, we're going to do density in here as dimensional analysis. That way we get all the algebra and all the converting done in one math step. So for tests, you do need to use dimensional analysis on these.